Hello everyone, and in this video we're going to be looking at question 6 of the 2012 Stage 2 Specialist Mathematics examination. So this is a question on quadratic iteration. It's worth 9 marks, and a lot of it is just simple analysis skills and understanding what happens with quadratic iterations. So of course we're given a table like we are given for most quadratic iteration questions, and we're asked to look at the long-term behavior of a specific iteration. As we can see, we're given the very common example of an iteration: z goes to z squared plus c, z0 equals 0, which is nice and easy, and c is equal to 0.3 plus 0.5i. So when doing this iteration, you can do it manually using technology, by getting z, then doing second function answer, putting brackets around it, squared plus c, but there is a quicker way, and I'm going to show you how to do this very quickly on a TI-84 so you can get your table done in no time at all, because that's a really easy 4 marks. As you can see, I've already gone ahead and done the question beforehand, but what we want to do is we want to put in our value of z0, and what we do is we have 0, and then we press this little button here, and I'll just show it to you. I'll just move it up. Stow. This button is magical, really. When you press stow, that button there, what happens is it comes up with a little arrow, and I want to stow that as a variable. I'm going to stow that as the variable x here. So now I've just officially put in 0 as x. So now what I need to do is insert my value of c, so I can input that. So I can obviously type in 0.3 plus, and then the rest of complex number, which is 0.5. And then what I do to get I is I need to do the second function button, and then I need to come down to the bottom here where you see that little I there. That's I for the complex number. Now I'm going to stow this again, so again I'm going to use the stow button, and I want to stow this as the variable c. So what I can do is I can put in text, so I can do alpha, the green button, and I want to stow it as c, so we can see that button's c. And I've effectively stowed that variable as c. So now I can do x squared plus c, because that's what I'm doing with the iteration, x squared plus c. And whatever that value is, I'm going to stow that in x. So again, I just hit the stow button to get that little arrow. So whatever my x squared plus c value is, that's going to go to x. So first iteration. Makes sense. Z is 0, so when we have z squared plus 0, 0 squared plus c, it's just going to be c. But now it starts to get a little bit interesting, because our entire value that we have for the first iteration is now going to be put into brackets, then squared, and then c is going to be added onto that. So that's where we start getting the interesting stuff happening in the iteration. But anyway, we write this value in our table, because this is n to the 1 for z n. So what we can do is we can just press this enter button. We get the second one, and we can write that in our table. Press the enter button again. We've got the third one, and then surprise, surprise, we've got the fourth one. So we're writing these in up until we get to the value of 6. Now, whatever you do, just be quite neat with your rounding. Make a good judgment call. You do want to show a decent number of figures because it comes in handy later, but don't get carried away. I mean, it's a 4-mark question. You've got a lot happening in the exam. So, again, just keep filling it out. But now what we want down the bottom are some values which are very, very large. So we keep pressing enter in order to get some very, very large values of z sub n. And we can start writing those into the table. So you just keep pressing enter, and it's going for all these iterations, and you note in the table they don't want any specific things, so just any iteration once you've done a few, because what we're doing here is we're effectively looking at the long-term behavior. So after a while you can stop, you can start writing in the values in the table again. As you can see, I've already done a few there. In question B, what we actually see is we get 4-cycle behavior. We can see this from the iteration, just by looking at the table. It's actually quite apparent from relatively early on. The values that it tends towards, which is also later in this question, isn't necessarily quite straightforward at the beginning. But what we have here, we can see that there's sort of a 4-cycle emerging. We have 0.3 plus 0.5i, 0.14 plus 0.8i, blah blah, and then we can see we also get in the fifth position, so after 4 different values in the fifth position we get something that's a little bit similar to the first. A little bit off, of course, because it's not a perfect 4 cycle, and we're looking at long-term behavior. It's tending towards a 4 cycle, but that sort of alludes to that prospect. And when we look at larger values, we start to see that more closely. We have 0.312 here, we have 0.314. They're very close together, so after 4 little dots, it repeats itself. Well, that's what it tends towards anyway. So 4 cycle behavior is appropriate there, and 5 marks just for doing some calculator stuff and for just recognizing that pattern. So this is where stuff starts to get a little bit interesting. Not too difficult though, if you understand what's going on with quadratic iterations. Next one is just about taking those 6 values that you got down the bottom here and just writing them all to 2 decimal places in the table below. I won't go through that too much because I'm assuming you can write two decimal places, those figures. That's relatively straightforward for 2 marks. But this is where the fun part begins. And of course, you're not expected to know a lot about the Mandelbrot set when you're looking at quadratic iterations. It's not actually part of the subject outline, but you should be able to plot points on an Argand diagram and sort of have a look for what's happening on the Mandelbrot set. Myself, I'm quite interested in the Mandelbrot set, so of course I have a little bit of knowledge which isn't associated with what's happening in the course. But plotting points isn't too difficult. You just take these 6 values that you see here, and what happens is we have a few values that lie close to the edges of the Mandelbrot set, and we have a few that lie outside the Mandelbrot set. But we see that it's generally a 4 cycle behavior, and sort of cycling in that form of a quadrilateral there around the Argand diagram. I won't go too much into the significance of that, but this is again just plotting points. So a lot of this is mainly a procedural quadratic iteration question. There are a few quadratic iteration questions which do get a bit more in depth. They don't necessarily look at the Mandelbrot set that much, but they do look at things like modulus and understanding arguments associated with iterations and using the triangle inequality. Those are generally section B questions. We're still in section A of the exam, so we're in the relatively straightforward procedural things. Section B video starts around about question 11 or question 10. Generally question 11, but we'll get into some of them soon, and that's when we start getting some interesting questions emerging. But that's just a straightforward procedural quadratic iteration question. Hopefully found it relatively easy to follow. Hopefully you also found it quite enjoyable. These are quite interesting when you look at the actual conceptual mathematics that go into the development of the Mandelbrot set and all these theories. Anyway, leave a comment below if you have one. Elsewise, I'll see you in the next video where we look at question 7.